For decades, we've been fed a cosmic fairy tale, the Big Bang, a singular moment, the absolute genesis, the universe, erupting from nothing in a flash of pure incandescence. It's a comforting story, isn't it? Simple, definitive. But what if I told you that story is a lie? What if the Big Bang wasn't the moment of creation, but merely a violent, cataclysmic aftermath, a cosmic echo of something far more profound, a primordial force that truly ignited existence, then vanished, leaving behind only the universe we see? What if our universe didn't just begin, but was triggered? Our story begins not with answers, but with a cosmic crime scene. For decades, the Big Bang model reigned supreme, a grand narrative of cosmic genesis, but lurking beneath its elegant surface were riddles that screamed defiance, inconsistencies so profound they threatened to unravel the very fabric of our understanding. They were the universe's whispers, hinting at a hidden chapter, a prologue of unimaginable power. First, the flatness paradox. Look around you. The universe is impossibly, uncannily flat, not curved like a sphere, not warped like a saddle. It's like a perfectly stretched trampoline. Here's the terrifying secret. For the universe to be this flat today, its initial density at the Planck moment had to be balanced with an accuracy of 1 part in 10^62. Think about that. That's like hitting a bullseye on a target across the entire observable universe, blindfolded, with a single arrow, a hair's breadth denser, and the universe would have collapsed back into itself in a cosmic instant, a breath lighter, and it would have expanded into a cold, empty void before stars could even spark. Our existence is a statistical impossibility, a cosmic tightrope walk performed with impossible precision. It screamed for an explanation. Then came the horizon problem. Peer into the deepest reaches of space, and you'll find the cosmic microwave background, the faint afterglow of the Big Bang. It's almost perfectly uniform in temperature. Everywhere you look, the cosmic thermometer reads the same. But here's the paradox. Regions on opposite sides of the observable universe are so far apart, light hasn't had enough time, even since the Big Bang, to travel between them. They've never been in causal contact, never talked. How could they possibly know to be the exact same temperature? It's like finding two strangers on opposite sides of the planet, wearing identical, custom-tailored suits, down to the last stitch. Despite never having met, never having a tailor in common, it defied logic, it defied physics, it screamed of a hidden hand. And finally, the monopole problem. Our most elegant theories of particle physics, the grand unified theories, predicted that the searing inferno of the early Big Bang should have forged vast numbers of exotic, super-heavy particles called magnetic monopoles. These are cosmic anomalies, isolated north or south magnetic poles, unlike anything we've ever seen. They should be everywhere, relics of the universe's first moments, as abundant as hydrogen. Yet we've searched, we've scoured the cosmos, and found absolutely nothing. Zero. It's a cosmic missing persons case, a recipe that must produce a certain ingredient, but the ingredient is simply gone, vanished. These weren't minor glitches. They were gaping wounds in the heart of our cosmic narrative. They were the universe itself whispering, then shouting, that the Big Bang, as we understood it, was incomplete. It was missing a crucial, explosive chapter, a hidden trigger. These paradoxes, these cosmic anomalies, haunted physicists like spectral whispers from the void. The universe was screaming that something was missing, a crucial piece of the puzzle. And then, in the audacious crucible of human intellect, a radical, almost heretical idea was forged: cosmic inflation. Imagine, if you will, not a universe born from an explosion in space, but space itself exploding, not expanding slowly, like a gentle breath, but inflating with a ferocity that defies comprehension. Picture a tiny primordial patch of reality, smaller than an atom, suddenly, in a fleeting fraction of a second, stretching, inflating, blasting outward by a factor of at least 10^26. That's a 1 followed by 26 zeros. If a single atom inflated by that much, it would become larger than our entire observable universe. This insane, mind-bending burst of expansion was driven by something called the Inflaton field. Think of the inflaton field not as matter or energy in the way we understand it, but as a field of pure, boundless potential permeating the nascent cosmos, like a cosmic spring wound impossibly tight, or a universe-sized credit card with an infinite limit ready to unleash unimaginable power. This field, hypothetical yet mathematically elegant, held within it the key to unlocking the universe's most confounding secrets. How did this singular, colossal inflation solve our cosmic conundrums? It's breathtakingly simple once you grasp the scale. The flatness paradox gone. Imagine drawing a small curve on a balloon. Now inflate that balloon to the size of a planet. That tiny curve, once obvious, now appears perfectly flat from your perspective. Inflation took the inherent curvature of the early universe, whatever it was, and stretched it so violently that any observable portion became indistinguishable from perfect flatness. It ironed out the wrinkles of reality, leaving behind the smooth, level cosmic tapestry we witness today. Our universe isn't perfectly flat by chance. It was made flat by the inflaton's furious expansion. The horizon problem, thus shattered. Before inflation began, that tiny primordial patch of reality was incredibly small, incredibly dense, and critically in causal contact. All its constituent parts could talk to each other. They thermalized. They reached a uniform temperature. Then, in an instant, the inflaton field ripped space apart, expanding it faster than light itself. Those once neighboring regions were propelled far beyond each other's horizons, leaving them isolated, yet retaining the identical temperatures they achieved before they were torn asunder. It's like baking a perfectly uniform cake, then stretching the dough to galactic scales before it sets. The uniformity was baked in, and the elusive monopole problem vanished. Those theoretical magnetic monopoles, those cosmic relics, were produced in the Big Bang. But inflation acted like a cosmic dilution agent. It diluted them to oblivion. Imagine just a handful of marbles scattered across a tiny room. Now imagine that room suddenly expanding to the size of a galaxy. Those few marbles would be so incredibly far apart, so sparsely distributed, that finding even one would be akin to searching for a single atom in an entire ocean. Inflation swept them away, scattering them so thinly across the vast inflated cosmos that the probability of detecting one in our observable universe becomes effectively zero. This theory, initially met with skepticism, offered a unified, elegant solution to problems that had plagued cosmology for decades. It didn't just explain away the paradoxes, it transformed our understanding of the universe's earliest moments from a chaotic explosion to a precisely engineered, albeit mind-bogglingly rapid, expansion. If you're ready to continue this journey through the most mind-bending theories of cosmic evolution, where the universe's story is far stranger than any fiction, then make sure to like this video and subscribe to the channel. We're just scratching the surface of what truly exploded the Big Bang. So we have this inflaton field, right? This cosmic credit card maxed out, stretching reality to impossible scales, smoothing out its imperfections. But a field wound that tight, a spring stretched to its breaking point, cannot hold its energy forever. It must release it. And when it did, the universe experienced something far more dramatic, far more cataclysmic than any conventional explosion. It experienced its true ignition. Imagine that inflaton field as a vast universal ocean of pure potential energy, silent, cold, empty, save for its own unimaginable tension. Then, in a moment that defies time, that ocean began to tremble. Its smooth surface rippled, then roiled, then collapsed. This wasn't a gentle dissipation. It was a quantum phase transition, a cosmic avalanche of energy. The field, unable to sustain its hyperextended state, began to decay. And here's where the magic, the true terror and wonder of the Big Bang reimagined, truly unfolds. As the inflaton field decayed, its colossal potential energy didn't just vanish, it converted. It transformed, like a dam bursting, unleashing a torrent. That pure field energy cascaded into a furious storm of fundamental particles, quarks, leptons, photons, all the raw ingredients of existence ignited into a searing, unimaginably dense plasma. This was the universe's reheating Andamenter. The moment the vast, cold, empty expanse created by inflation was suddenly, violently filled with the blazing inferno we mistakenly call the Big Bang. It wasn't the start out of everything from nothing. It was the end of inflation. The glorious, furious transfer of energy from one state to another. Think of it like a cosmic furnace suddenly switched on, incinerating the very vacuum of space with matter and radiation. This wasn't a static explosion from a point. This was the entire fabric of space, already vastly expanded by inflation, suddenly bursting into light and heat everywhere at once. The universe didn't explode into space. Space itself, already enormous, became incandescent. The temperatures soared to dizzying heights, exceeding anything we can possibly imagine, creating the perfect conditions for the birth of every particle, every atom, every star, and every galaxy that would ever exist. The Big Bang, therefore, wasn't the genesis. It was the aftermath, the incredible, violent, and utterly fundamental consequence of the inflaton field's grand collapse. It was the universe catching fire, not from a spark, but from the sudden, unleashed fury of a primordial power that had already shaped its very geometry. Our universe didn't just appear. It was born from our cosmic crescendo, a moment of ultimate energy conversion that set the stage for everything that followed. It's a story of transformation, not just creation, and it's far more brutal and far more beautiful than the simple bang we once imagined. The story of the inflaton field, the hidden trigger behind our Big Bang, doesn't end with a single magnificent explosion. Oh no, that would be far too simple, far too limited for the cosmos we're uncovering. The true mind-bending implication of inflation theory is a concept so vast, so profound, it will shatter your perception of reality itself, the multiverse. You see, the inflaton field, that cosmic spring, that ocean of potential, doesn't just decay uniformly, like a single perfect burst across all of existence. The rules of quantum mechanics, those bizarre, unpredictable whispers at the heart of reality, forbid such neatness. Instead, the inflaton field is engaged in a perpetual, frenzied dance of creation and decay. Imagine a vast primordial ocean, but this ocean is not made of water. It's made of pure inflating space, and this ocean is not calm. It is boiling, continuously, relentlessly. New bubbles are spawning on its surface. Each bubble is a region where the inflaton field has decayed, releasing its energy and igniting a Big Bang, just like the one that birthed our universe. But around these decayed patches, the rest of the ocean, the bulk of the inflaton field, continues to expand exponentially. It keeps inflating forever. This is the chilling, majestic concept of our eternal inflation. It dictates that once inflation starts, it never truly stops. It's like an infinite, self-replicating cosmic factory, perpetually churning out new realities. Our Big Bang wasn't a unique event. It was just one bubble, one hot, dense pocket born from the ceaseless, frothing expansion of the underlying inflaton field. Think of it as an infinite branching river. Our universe is just one tributary, flowing from a single cataclysmic waterfall, our Big Bang. But upstream, the river continues to fork and divide, creating an endless network of new streams, new waterfalls, new Big Bangs ad infinitum. Each branch is a separate, self-contained universe, an individual cosmic bubble. And here's where it gets truly wild, because each of these bubble universes could be born with slightly different physical laws. Imagine a cosmic lottery where the fundamental constants, the speed of light, the strength of gravity, the mass of an electron, are spun anew with each Big Bang. Some universes might be sterile, collapsing instantly, or expanding into cold nothingness. Others might be subtly different, with atoms that can't form or stars that can't ignite. And then there are universes like ours, where the numbers just happen to be perfectly aligned for the emergence of complexity, for stars, for planets, for life, for sect. This isn't just theoretical speculation. Eternal inflation emerges as a logical, almost inevitable consequence from the very quantum mechanics that govern the inflaton field. Our universe, vast as it seems, might be nothing more than a single, infinitesimally small blip in an infinite, ever-spawning cosmic tapestry, a solitary grain of sand on an eternal beach where every grain is an entire universe. The Big Bang, then, is not the ultimate origin. It's a local event, a glorious, violent birth, yes, but one of countless others. Our universe is merely a child of this greater, eternal, inflating multiverse. It fundamentally shifts our cosmic address from being the universe to being a universe. It redefines our very existence, placing us within an unimaginably vast, perpetually creating cosmic ecosystem. The search for the ultimate origin doesn't end with the Big Bang. It simply deepens, revealing an infinite, terrifyingly beautiful cosmic frontier. So, what truly exploded the Big Bang? It wasn't a spark from nothingness, but the furious, liberating decay of a primordial energy field, the inflaton, that had already stretched reality beyond all comprehension. Our universe, vast and magnificent, is merely the incandescent aftermath of an even grander, more violent cosmic act, and that act itself might be just one of an infinite, eternal symphony of creation playing out across a boundless multiverse. This isn't just a different origin story, it's a profound shift in perspective. It tells us that the universe is not a static canvas, but a dynamic, ever-birthing entity. It humbles us, reminding us that our entire observable cosmos might be just a single fleeting bubble in an ocean of infinite realities. It forces us to confront the possibility that existence is far more vast, far more complex, and infinitely more bewildering than we could ever have imagined. The Big Bang wasn't the beginning. It was merely a magnificent transition, a cosmic handoff from a hidden, inflationary epoch. And that, my friends, is the thrilling, terrifying beauty of cosmic discovery. Each answer we find simply unleashes 1,000 new, more profound questions. The search for knowledge isn't about finding the final truth. It's about the eternal chase, the relentless pursuit of understanding in a cosmos that never ceases to astonish. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.